When class will start actually? It's already 4 o'clock.
Am I audible?
Yes, sir.
So we were discussing solution of differential equation and specifically partial differential equation with variable coefficients by using power series method and your Frobenius method. Am I right?
Yes, sir.
So I have given you a homework to try to solve the differential equation like Bessel's, Legendre, Hermite, etc. by using Frobenius method or power series solution, any of this. Frobenius method is the extended power series or quasi power series. So any of you tried this and be successful? Please
Yes,
respond.
sir.
So please, I have told that past 15 minutes we shall discuss this. So please show your screen. Your notebook. Please share in the screen. Anybody else? You are now around 33 students. So how many of you have tried and successfully derived any of these differential equation? Please write in the message box. Anybody? No. Anybody else? So I think one or two students might have done it. Most of the people could not got time to solve it. So I think you try it today also, and tomorrow we shall discuss these differential equations which are having variable coefficients. And one of the other unit is related with the complex numbers and complex integration. So let us discuss the preliminary part of that unit so that you can get time to solve these differential equations. Okay? Please respond.
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes, sir.
So what is a complex number? Anybody?
Which cannot be obtained in real.
Okay. Anybody else? Anybody else?
Express IUI.
You might have come across numbers like 1, 2, 3, 4, 5, 0, negative numbers like -1, -3, -5, -7, -9, so on and so forth, or fractions like 27 by 22 by 7, 1 by 3, root of like this. Okay, so these are having numbers or fractions. They form the real number, which can be expressed in Cartesian coordinate system. Okay, but there are certain numbers which cannot be represented by these numbers or fractions. Suppose I have to represent root over of -1. So root over of -1 cannot be expressed in a real number system. Root over of -4, which is nothing but 4 multiplied by root over of -1. It cannot be represented in a real number system. So for this, we use a different notation, and it can be expressed in a complex number format. Your x square plus 1 is equal to 0. This is a polynomial equation. If you solve it, you can find that x square is equal to -1 and x is equal to root over -1. So this cannot be represented in a real number system. So here you have in a plane, you have one real axis and another imaginary axis. So in real axis, you place your numbers like 1, 2, 3, 4, -5, 22 by 7, these things. In imaginary axis, you can place it as a as I multiplied by some number. I is nothing but root over of minus 1. So you can write A plus IB. A can be any number, B can be any number, and I is a imaginary number or complex number. So your complex number Z can be represented in a format A plus IB, where A and B are numbers and I is nothing but root over of minus 1. So you can write I square is equal to minus 1, I cube is equal to minus I to the power 4 is equal to 1, I to the power 5 is equal to I to the power 6 is equal to minus 1, I to the power 7 is equal to minus I to the power 8 is equal to 1, I to the power minus 2 is equal to minus 1, I to the power minus 3 is equal to I, so on and so forth. So you can have a generalized expression I to the power plus minus 4k is equal to 1, I to the power plus minus 4k plus 1 is equal to plus minus I to the power plus minus 4k plus 2 is equal to minus 1, I to the power plus minus 4k plus 3 is equal to minus plus I, so on and so forth, where your k is equal to 0, 1, 2, so on and so forth. So if you write I to the power 100, this is nothing but I to the power 4 multiplied by 25. You can write I to the power 99. This can be written as I to the power 4 multiplied by 24 plus 3, which is nothing but I. Okay. So complex number Z can be represented in a argand plane where your x-axis is the real axis and y-axis is the imaginary axis. So Z can be represented as A plus IB, where J is the value of the x coordinate. If you drop a perpendicular from the point P and it is a real number A. If you drop a perpendicular to the imaginary axis in the argand plane, then the value is B and your y component is IB. Are you getting it?
Yes, sir.
So
Yes,
this is the
sir.
geometrical
Explain the coordinate system.
representation of complex numbers and complex plane. You know it. Any doubt? Anybody has raising some questions?
Sir, explain the coordinate system now you told, like x-axis, y-axis.
Yeah, I am showing it in the picture. You can, I am enlarging it. Please see, this is the geometrical representation of a complex number. Suppose you have a point P or the position vector is Z. So if you drop a perpendicular in the real part, then this is nothing but your A, which I am showing here. And if you drop a perpendicular in imaginary axis, and the value will be B here, then it is IB. Z can be represented as A plus IB in the argand plane. This type of notation is
Sir, your voice is not audible.
Am I audible now?
Yes, sir.
So there might be some internet issues. For that reason, there may be some fluctuation in the voice. So suppose you have a number 5 plus 7i, 5 plus 7i. Then 5, if Z is equal to 5 plus 7i, then the complex conjugate can be written as Z star, which is 5 minus 7i. So if you replace the plus sign with a minus sign, then it will be the complex conjugate of that number. And what it represented geometrically? It is represented by a symmetrically situated point in the complex plane or argand plane and in the other side. So your modulus of Z star is equal to root over of x square and y plus y square. So the modulus of a number and its complex conjugate is same. Okay. So if you have a number 7 minus 3i, then its complex conjugate will be 7 plus 3i. You can also represent a complex number in a polar form. It is another important notation or representation. You can see it in the picture. This is represented in a polar coordinate system, that is r and theta. So your x is equal to r cos theta and y is equal to r sin theta, and r is equal to root over of x square plus y square, which is nothing but modulus of z. So your z can be represented as r cos theta plus I r sin theta. So yeah, I is root over of minus 1, and it is a complex number. Z is a complex number. So you can also write z is equal to r cos theta plus I sin theta. And you know cos theta plus I sin theta can be represented in a exponential form. Cos theta plus I sin theta can be written as e to the power I theta. So your z can be written as r e to the power I theta, which is the polar form of the expression z. And your angle theta can be measured from the positive x-axis by dropping a perpendicular from P. So it is measured in radians and is chosen as positive in the counterclockwise sense. So you can see that theta is in a counterclockwise direction from the x-axis. The angle theta is measured from the positive x-axis and it is in a counterclockwise direction, anti-clockwise direction. And your theta is also popularly known as argument of z, or you can write it as argz or argz. And the amplitude of z is represented by z only. So theta is nothing but argz or amplitude of z or tan inverse y by x. Okay. Then roots of complex number. If you know all these things, I can skip and go to complex integration and other things. Do you know
Yes,
this, or I shall explain?
yes, sir. Yes, sir. You move, sir. First.
You want to, you know it?
No, sir. Actually, my question is using complex analysis. What you find out actually? This is the complex number we study in class 12 also.
In your syllabus, there is
Huh?
complex analysis. And from complex analysis, look, after introducing you to complex analysis, I shall explain you about the analytic function. Okay? And Cauchy-Riemann equation and other things, and complex integration and residue theorem, and how can you solve expressions using residue theorem and these concepts. Okay? You can see. Do you have studied it earlier? Please see in the screen. You know these things, then I keep and go to the other part.
Yes, sir. We know this.
You know all this? Please see in the screen. If you know, then I can skip and go to the next part. You know it? Please see in the screen. Is it visible? Please see in the screen. Is the screen visible?
Yes, sir. Yes,
Yes,
sir.
sir.
Do you know these things?
No, sir. Cauchy-Riemann equation you start.
Okay.
No, analytic function you start. Analytic
Analysis.
function.
Anybody else? Anybody else? Okay. So I think
Sir, from
everybody.
analytic function.
Okay. So I think I shall start from here. So you might have a function f, which is a function of z, where z is a complex number. and can be represented in a form x plus iy or a plus ib. So a function f is said to be analytic at a point z is equal to z0 if it is defined and has a derivative at every point in some neighborhood of z0. Are you getting it? Fz is said to be analytic at a point z is equal to z0 if it is defined, and most importantly, it has a derivative at every point in some neighborhood of z0. So let us explain it. And that neighborhood falls in the domain D. It is said to be analytic in a domain D, where D constitutes the neighborhood of that point z0 if it is analytic at every point in D. Analytic functions are also called regular or homomorphic functions. Functions like sin theta, sin z, cos z, and e to the power z are analytic functions. So, there are some criteria which will help you to decide whether a function is analytic or not. There is some mathematical technique to test whether a function is analytic or not. If you have the definition, then there is a domain D on the vicinity of a point z0, and in that domain D, if the function is analytic and its derivative at every point has some value, then we can say it analytic function. So there is a mathematical technique which will also make you know whether a function is analytic or not, and that is called Cauchy-Riemann equation. So let us discuss Cauchy-Riemann equation. So you know f can be expressed in form of a real number and I multiplied by some real number and addition of those two parts. So let us f, which is a function of z, can be represented as u plus iv, where u and v are functions of x comma y. Okay, and u represents the real part of fz and v represents the imaginary part of the fz. Suppose at a point z in the complex plane, u and v possesses first order practical derivatives, partial derivative, first order partial derivative, del y by del x format. With respect to x and y, then the derivative of fz with respect to z is defined as f dash is equal to limit del z tends to 0, del z tends to 0, f of z plus del z minus f of z by del z, which is nothing but limit del z tends to 0, del f z by del z. And your f of z is equal to limit del z tends to 0, del u plus I del v divided by del x plus I del y. Let us explain it like this. So see in the figure 3.5, you have a x-axis and you have a y-axis, and there is a point. So your del x is equal to 0 and del y tends to 0 when it approaches from the x-axis. When you approach it from the y-axis, then del x tends to 0 and del y is equal to 0. So there are infinite number of ways of obtaining the limit del z tends to 0 in the z plane. For a derivative to exist, we demand that f dash be unique as del z tends to 0. Regardless of the path chosen, whether you approach from the x-axis or you approach from the y-axis, your del z tends to 0. For convenience, we consider two approaches as shown here in the screen. So let us discuss the first one, case 1, where you approach the point from x-axis. So if you approach the point from x-axis, then your del x is equal to 0 and your del z tends to 0 and your I del y tends to 0. So your f dash, f of 1, first derivative of f1, or that is del f1 by your del z is equal to limit del x tends to 0, I del y, limit del x is equal to 0 and I del y tends to 0, your del u plus I del v by del x plus I del y. So this is nothing but limit del y tends to 0, del u plus I del v divided by I del y, because your del x is equal to 0. So your del x plus I del y is equal to I del y only. So you can write f dash is equal to minus I del u by del y plus del v by del y. In the second case, when you approach the point from y axis, then your del y is equal to 0 and your del x tends to 0. So you can write f of 2 dash, where f of 2 dash is equal to limit del x tends to 0, I del y is equal to 0. So you can have your I del y term 0. So you remain with limit del x tends to 0, del u plus I del v divided by del x only. So this is nothing but del u by del x plus I del v by del x. So for fz to be analytic in the region R, we need f1 dash is equal to f2 dash. जो भी अप्रोच से जाएगा del z हमें 0 चाहिए. So whether we shall proceed from the x axis or from the y axis, we have the first derivative need to be 0. So that means f1 dash is equal to f2 dash. So if you equate equation 3.16 and equation 3.17 as shown in the screen, your minus I del u by del v plus del v by del y is equal to del u by del x plus I del v by del x. Okay, so this is nothing but equating the real parts and imaginary parts from both sides. So real part constitutes in the left hand side del v by del y and in the right hand side del u by del x. So the real part must be same. So your del u by del x is equal to del v by del y, and the imaginary part must be same. So your I del v by del x is equal to minus I del u by del y. So your del u by del y is equal to minus del v by del x, which is nothing but Cauchy-Riemann condition. So in Cauchy-Riemann condition, what we see? We see that if a function z is represented as u plus iv, then where u and v are the function of x and y, then your del u by del x is equal to del v by del y, and your del u by del y is equal to minus del v by del x. Okay. So the Cauchy-Riemann equation have been derived on the restrictive assumptions while taking the limit z del z tends to 0. Here we have considered only two specific convenient paths, one from x-axis, another from y-axis, and one is parallel to y-axis and another parallel to x-axis. As a result, it is a general form. So the conditions are necessary, not sufficient conditions to decide whether a differentiable or not. So what is the sufficient condition? That fz to be analytic. The continuous single valued function fz, which is nothing but u plus iv, where u and v are functions of x and y, is analytic in a region capital R if the four partial derivatives del u by del x, del u by del y, del v by del x, del v by del y exist and continuous and satisfy the Cauchy-Riemann equations at each point of the region R. So here is the proof. You can also try. So here you can see that df by dz is equal to del u by del x plus I del v by del x. Okay. And your fz is differentiable. So this proves that it is a sufficient condition to find whether a function is your analytic or not. So another is polar form of Cauchy-Riemann equation. I think it is not there in your syllabus, but you can have it if you try for some examinations, entrance examination like GATE and NET. Okay. So in polar form, you know there are two variables. One is theta, another is r. So your r is equal to x square plus y square to the power half, and theta is equal to tan inverse y by x. And your x can be represented as r cos theta and y can be represented as r sin theta. So in the polar form, you have your del u by del r is equal to 1 by r del v by del theta, and your del v by del r is equal to minus 1 by r del u by del theta. Okay. So for Cauchy-Riemann equation in a polar form, you can say that del u by del r is equal to 1 by r del v by del theta, and del v by del r is equal to minus 1 by r del u by del theta. If these two conditions satisfy, then you can say that the function is analytic function. Then another important thing is derivative of the fz in polar form. So you have your f dash z is equal to e to the power minus I theta multiplied by del u by del r plus I del v by del r, and the proof is shown in the screen. So there are some worked out problems. You can have this and attend if it is been there in your examination, and you can also understand it very beautifully whether a function is analytic or not from these examples. Okay.
Can you solve the example? One example.
I have solved it. Let us have the first one. I have already
One.
solved it and showing in the screen. Suppose a function fz is equal to z square. So let us test whether it is analytic or not. It is showing in the screen. Is it visible?
Yes, sir. Yes, sir. Continue.
Okay. So
Yes, sir.
fz is equal to z square. You know z is equal to x plus iy. You can have it also u plus iv. So for simplicity, I am writing z is equal to x plus iy. So your z square will be obviously x plus iy square. So if you have it, then your x plus iy square is nothing but a plus b square की तरह आप उसको देख कर सकते हैं. So a plus b square is nothing but a square plus b square plus 2ab. So here your x plus iy square is equal to x square plus iy square. So iy square is equal to I square plus y square. So I square is equal to how much? Minus 1. Hence I have explained it in the first part of the discussion. See here. I square is equal to minus 1. IQ is equal to minus 1. अभी मैं बोल रहा था
Yes,
ना आपको.
sir.
ठीक है. So let us put
Yes,
that
sir.
on in the example. So see, your x square is equal to x square. Iy whole square is equal to I square plus y square is nothing but minus 1. Y square is equal to minus y square. And your 2hiy, that is nothing but I2xy. Are you getting it? So your z square is equal to x square minus y square plus I2xy. So this can be represented as u plus iv form. So here your u is equal to x square minus y square and your v is equal to 2xy. Okay. So what is the Cauchy-Riemann equation? Cauchy-Riemann equation is, you have to see first del u by del x, real part, then del v by del y, del u by del x, del v by del y. Okay, if both are same, then the first condition will satisfy. So your del u by del x is equal to how much? Del u by del x is equal to del x square minus y square by del x. So this is nothing but 2x. Are you clear?
Yes, sir.
Yes, sir.
Yes, sir.
Del u by del x is equal to del x square minus y square by del x. So y square will remain as if a constant की तरह behave करेगा, हम use करेंगे. So derivative of a constant is equal to 0 in a partial derivative. And for x square it is 2x. X to the power n is equal to n, x to the power n minus 1. Are you getting it?
Yes, sir.
sir.
Yes,
Yes,
sir.
sir.
Your v can be written as del v by del y, so del 2xy by del y. So this is 2x del y by del y is equal to 2x 1. 2x multiplied by 1 is equal to 2x. Are you getting it? So del v by del y is equal to
Yes,
2x.
sir.
So the first condition is del x is equal to del v by del y is equal to 2x. देखिए फर्स्ट कंडीशन यही था ना, तो पोलर फॉर्म नॉर्मल हमने आपको बताया था. फर्स्ट क्या था?
Hello, sir.
del x is equal to del v by del y. नहीं, ये कंडीशन
Sir,
हमारा
only
satisfy हो गया.
सर ये दो कंडीशन सिर्फ दिखाना है, बाकी जो बाउंड्री कंडीशन के बारे में आप बताए थे वो नहीं दिखाना है कि
क्या बताया था?
हेलो,
कहाँ बताया था बाउंड्री कंडीशन के बारे में?
सॉरी सर,
बाउंड्री कंडीशन मैंने कब बोला था?
आप पहले कच्चीस राइमन इक्वेशन डिराइव
पहले हम
कीजिए, फिर
डिफरेंशियल इक्वेशन पढ़ा रहे थे, आज कॉम्प्लेक्स वेरिएबल पढ़ा रहे हैं। बाउंड्री कंडीशन आता है डिफरेंशिएशन इंटीग्रेशन में। जब हम कॉम्प्लेक्स इंटीग्रेशन करेंगे तब बाउंड्री कंडीशन के बारे में बताएंगे, ठीक है? वो पिछले क्लास दूसरा यूनिट था, आज दूसरा यूनिट है।
only these two conditions
आर यू
are to
गेटिंग इट? आज मैंने कहीं भी बाउंड्री कंडीशन वर्ड यूज नहीं किया, सो फार आज आई रिकॉल।
आप
ओके,
ठीक है
हमने
सर।
आज क्या, ये एनालिटिक कैसे होगा, ये कच्ची रिमांड कंडीशन से आपको पता चलेगा। कच्ची रिमांड कंडीशन क्या
नहीं,
है?
वो तो समझ में आ गया, वो सिर्फ डेरिवेटिव निकालना है, वो तो हो जाएगा।
वही तो बता रहे हैं ना, जितना जितना बता
नहीं
रहे
तो
हैं पहले उसको एक करते जाए, क्योंकि यू हैव 50 स्टूडेंट्स, आउट ऑफ दो 5 में भी वेरी एडवांस, नहीं बिना बताने से भी वो 100 से 100 ले आएंगे, बाकी 45 को भी साथ लेके चलना पड़ेगा ना। तो स्टेप बाय स्टेप
ओके ओके
जाएंगे,
सर, यू कंटिन्यू।
you will be
ओके,
benefited also. But you have, if you want something else, then you can also proceed likewise. क्या बोल रहे हैं बाकी बच्चे?
Yes, sir. We are saying the same thing.
जिसको पता है तो थोड़ा, बाकी बच्चों के लिए वो सब्र करे, बाकी सबको लेके साथ चलेंगे ना। तो एनालिटिक होने के लिए ये दो कंडीशन हमें चाहिए जो स्क्रीन पे दिख रहा है। पहले कंडीशन हमारा हो गया डेली बाई डेली बाई 2 सेकेंड बार क्या है, बनाया बी के साथ x। अब क्या होगा देखिए यहाँ, usually respect हुआ
Sir, your voice is not clearly. No, sir. It's not clear.
दिख रहा है स्क्वायर माइनस एंड b इक्वल टू y दिख रहा है?
Sir, nothing is audible and visible.
इसमें है u
Sir, your voice is not clear.
इज इट क्लियर ना? मैं क्या करूँ, ये तो इंटरनेट प्रॉब्लम है ना।
Yes,
तो
sir.
थोड़ा
Now
वेट
it is
करते हैं या
clear.
फिर डिस्कनेक्ट होके। ओके,
No, no, sir. It's
सो
now
योर
clear.
ओके ओके, सो ठीक है। सो डेल यू बाई डेल वाई इज इक्वल टू डेल सम कांस्टेंट बाई डेल वाई इज इक्वल टू 0 एंड माइनस ऑफ डेल वाई स्क्वायर बाई डेल वाई। सो दिस इज नथिंग बट माइनस ऑफ 2y, ठीक है, माइनस ऑफ 2y। अब डेल बी बाई डेल वाई क्या होगा? डेल बी बाई डेल एक्स, डेल यू बाई डेल वाई देन डेल बी बाई डेल एक्स। डेल बी बाई डेल एक्स इज इक्वल टू डेल ऑफ 2xy बाई डेल एक्स। सो Am I audible now?
Yes,
Yes,
sir.
sir.
I think I have been disconnected. So
Yes, sir.
let us join again. ठीक है, अब
Yes, sir.
कहाँ तक आपने सुन पाया ये भी पता नहीं. ठीक है, सो कच्ची रिमान कंडीशन क्या है? स्क्रीन दिख रहा है? कच्ची रिमान
Yes, sir.
कंडीशन क्या है? रिमान कंडीशन क्या है? U and V both are functions of x and y. Okay, so del u by del x, u भी x y, u पहले आता है, v बाद में आता है, x पहले आता है, y बाद में आता है आपका अल्फाबेट में नहीं. सो दो कंडीशन है. डेल u बाई डेल एक्स जो पहले आता है, डेल u बाई डेल एक्स इज इक्वल टू डेल v बाई डेल वाई. फिर हम क्रॉस करेंगे. डेल u बाई डेल वाई इज माइनस ऑफ डेल v बाई डेल एक्स. ये दो कंडीशन है. आर यू गेटिंग इट?
Yes, sir.
तो यहाँ भी हमने देखा डेल यू बाई डेल एक्स इज इक्वल टू डेल वी बाई डेल वाई इज इक्वल टू 2x एंड योर डेल यू बाई डेल वाई इज इक्वल टू माइनस 2i एक्स इज इक्वल प्लस 2y. सो माइनस हो गया, दोनों कंडीशन सेटिस्फाई. सो योर एफ जेड इज इक्वल टू जेड स्क्वायर इज द एनालिटिक फंक्शन. आर यू गेटिंग इट?
Yes, sir.
Similarly, you can test that z to the power n is the analytic function. ठीक है, सो हियर पोलर फॉर्म विल बी वेरी मच यूजफुल. पोलर फॉर्म लेके आप इसको देख सकते हैं. देन यू कैन ऑल्सो सी जेड जेड स्टार कॉम्प्लेक्स कॉन्जुगेट एनालिटिक हो भी सकता है, नहीं भी हो सकता है, इफ जेड इज एनालिटिक फंक्शन. देन यू कैन सी दैट जेड स्टार टू द पावर n के लिए क्या होता है. ठीक है, ये सारा हमने यहाँ डिराइव करके दिखाया है. देन यू कैन सी द रीजन ऑफ एनालिटिसिटी क्या हो सकता है कॉस जेड फंक्शन के लिए. रीजन ऑफ एनालिटिसिटी क्या हो सकता है एक फंक्शन ई टू द पावर जेड के लिए. रीजन ऑफ एनालिटिसिटी क्या हो सकता है फंक्शन और लॉगरिथम फंक्शन जो है एफ जेड इज इक्वल टू एल एन जेड के लिए. ओके, देन योर एफ जेड अगर होगा जेड टू द पावर एन और आर टू द पावर एन, देन वहाँ पोलर फॉर्म यूज करके हम क्या देख सकते हैं या नहीं, ये एनालिटिक है या नहीं. ओके, कुछ आपका जो मटेरियल है कोर्स मटेरियल वहाँ से भी कुछ करेंगे. देन यू विल बी वेरी मच वेल एक्वेंटेड विद दीज थिंग्स. देन वी शैल डिस्कस एनालिटिसिटी एंड
Hello, sir.
बताइए सर.
Sir, when you taught, you said polar form is not in the syllabus.
अरे भाई, अगर आप नहीं बोलेंगे नहीं पढ़ाएंगे क्या? आप नहीं बोलेंगे तो नहीं पढ़ाएंगे, इसलिए तो उसको मैं ज़्यादा, जैसे हमने कार्टेशियन कोऑर्डिनेट सिस्टम में डेरिवेटिव को डिटेल बताया, डिटेल में पोलर फॉर्म को इतना डिटेल बताया क्या? और और इन्फॉर्मेशन हमने बता दिया. बाकी आपको जिनको पता चाहिए वो उसको सुनेंगे, करेंगे, जिन नहीं चाहिए नहीं करेंगे. ठीक है,
सिलेबस में नहीं है लेकिन.
You can have observed that in Cartesian coordinate system, I have derived I have shown you the detailed derivation and each and each bit of that derivation. But in polar form, I just skip because
Okay.
okay. तो ऐसा भी नहीं है जो मैं पढ़ा रहा हूँ सब आपका एग्जाम में आएगा, नहीं. आपका जो कोर्स मटेरियल है उससे आएगा और बाकी वो जो सेटअप कर रहे हैं क्वेश्चन उनमें से आएगा. ऐसा नहीं है कि मैं जो पढ़ा रहा हूँ आएगा, जो नहीं पढ़ा नहीं रहा हूँ वो नहीं आएगा. ओके
Okay, sir.
ठीक है. देन वी शैल डिस्कस एनालिटिसिटी एंड लाप्लास इक्वेशन. A real valued function phi of x and y is said to be harmonic in a given domain capital D if the xy in the xy plane if throughout that domain it has continuous partial derivatives of the first and second order and partial differential equation del square phi by del x square plus del square phi by del y square is equal to 0. It is known as Laplace equation. You might have come across this Laplace equation in physics and engineering in your BSc days. So, if you consider a single valued function fz whose real and imaginary parts are u and v respectively, then f is equal to u plus iv, where u and v are functions of x and y. or x comma y. And fz is analytic, so your Cauchy-Riemann equation must be satisfied. That is, del u by del x is equal to del v by del y, and del u by del y is equal to minus del v by del x. So differentiating the first equation with respect to x and the second equation with respect to y and adding them, you can obtain del square u by del x square plus del square u by del y square is equal to del square v by del x del y minus del square v by del y del x. So the continuity of the partial derivatives ensures that del v by del x del y is equal to del square v by del x del y is equal to del square v by del y del x. Consequently, you can have del square u by del x square plus del square u by del y square is equal to 0, or your delta square u is equal to 0, which delta square is equal to del square by del x square plus del square by del y square is equal to 0, which is nothing but Laplacian operator. This equation is 0 is Laplace. Now, 0, that is del square by so functions u and v, which are the double and integer and the d plus equation in capital. The u and v are function domain, and your v is called harmonic conjugate of u and vice versa. Function v may be obtained from via Cauchy-Riemann equation. Okay. Then we shall discuss harmonic conjugates. Harmonic conjugates in hyperbolic functions and logarithmic functions. If given functions u and v are harmonic in domain D and their first order partial derivatives satisfy the Cauchy-Riemann equation throughout D, v is said to be harmonic conjugate of E. However, it is not in general true that u is harmonic conjugate of v in domain capital. If a function fz is equal to u plus iv is analytic in a domain capital D, v is a harmonic conjugate of E. Okay. This statement can be used to redefine an analytic function in the following manner. The necessary and sufficient condition for a function fz is equal to u plus iv, where u and v are functions of x comma y, and f need to be analytic in a domain D, so that v must be harmonic conjugate of u in D. So if fz is analytic at a point z, if its derivative exists not only at a z0 but also at each point in the neighborhood of z, and your fz is analytic in a region R if it is analytic at each point in R. Analytic functions are usually defined on domains. A function which is analytic at each point in the finite plane is called an entire function. Okay. And e to the power x, cos z, sin z, these are entire functions. Then complex form of exponential, trigonometric, and hyperbolic and logarithmic functions, you can have derive it. Okay. Circular or trigonometric function and your hyperbolic function. Okay. ln z1 by z2 is equal to ln z1 minus ln z2 is equal to r e to the power I theta. Your in hyperbolic case, your sin iz is equal to I sin hz, sin hiz is equal to I sin z, tan iz is equal to I tan hz, tan hiz is equal to I tan z. In case of your circular function or trigonometric function, your sin z is equal to e to the power iz minus e to the power minus iz by 2i. Cos z is equal to e to the power iz plus e to the power minus iz by 2. And your tan z is equal to e to the power iz minus e to the power minus iz by I multiplied by e to the power iz plus e to the power minus iz. So this can be used in your problems when you work out those things. So next step.
Sir, domain. Domain.
There is two things. One is domain, another is range. Okay. Domain is represented by D and range is represented by I.
No, sir. If FZ is analytic in domain D, so what does it mean actually? I'm asking.
Okay. In a neighbor of Z0, that region is called domain. And when you find out the residue theorem, you can see how domain and range things are being there, and you can have your solutions from those ideas. तो डोमेन का मतलब क्या है? आप डोमेन क्या समझते हैं? डोमेन जो है तो पहले की प्लस 2 में आपने पढ़ा होगा ना, 11th 12th में, ये इसमें शायद
भूल गया सर.
It contain function
डोमेन और रेंज क्या है? हाँ
In content
and range
function. Okay.
contain elements.
हाँ, तो इट इज सेट. आप जब सेट के बारे में, सेट ऑफ पॉइंट्स और सेट ऑफ डिफरेंट पॉइंट्स वेयर यू आर डिस्कसिंग समथिंग. Range is a region up to which you can discuss those things. Okay.
Sir,
So I think next
Sir.
class is of Dr. Naik. हम बताइए.
sir, I have a doubt.
हम बताइए.
Sir, if a function satisfy the Cauchy-Riemann equations or the condition,
Yes.
then this
Yes.
function is also called analytic or not?
Now, if a function satisfy Cauchy-Riemann condition, it is the necessary condition to be analytic. It is the necessary condition to be analytic. Cauchy-Riemann condition अगर satisfy नहीं करेगा तो analytic का सवाल ही नहीं आता है. ठीक है. सो इसलिए तो हम हमेशा Cauchy-Riemann condition देखते हैं, satisfy करता है या नहीं करता है. Then the second part is whether it is sufficient or not. It is not the sufficient condition which I have discussed earlier. Okay.
Yes, sir.
Sufficiency condition of FZ to be analytic ये मैंने discuss किया ना.
Yes, sir.
Sufficient condition क्या है? Your del u by del x, del u by del y, del v by del x, del v by del y must exist. These four partial derivative must exist and they must be continuous. Okay. अगर वो exist ही नहीं करेगा और continuous नहीं होगा, आगे Cauchy-Riemann condition के ओर जाने की जरूरत ही क्या है?
जी जी.
ये तो मैंने डिस्कस किया ना. डेरिवेटिव मैंने डेरिवेशन मैंने डिटेल में आपको टाइम नहीं है इसलिए बताया नहीं, इसलिए शायद यू हैव स्किप्ड इट. ओके.
Okay. Yes.
अच्छा ठीक है, हम बताइए और एनी डाउट?
Sir, can you discuss all the SQ and FQ that we have at the end of each topic in IGNO books?
सारा कर देंगे. ठीक है.
Okay, sir.
तो दूसरा चीज क्या है, आज नेक्स्ट क्लास इज ऑफ डॉक्टर नायक. अगर वो ज्वाइन नहीं करते हैं फिर हम देखेंगे. दूसरा बात है, कल और परसों आप क्लास में आ सकते हैं क्या? ये तो ऑनलाइन है.
Yes, sir.
Yes, sir.
कल कितने बजे? 5 o'clock.
4 to 6, 5 o'clock.
5 o'clock कल हम क्लास ले लेंगे. अगर ईच एंड एवरी पार्टिसिपेंट विल एग्री तो जल्दी आपका कवर हो जाए.
Yes, sir. Sir, in the same link we will join.
हाँ, in the same. And it will be recorded accordingly.
Okay.
Sir, today's important question from the class.
हाँ बताइए ज्ञान जी.
Sir, today's important question what you taught.
Do you think anything is not important today what I explained? For me तो everything are important.
Sir, everything for the examination what you tell.
You will decide कौन सा important है या नहीं.
If SQ and FQ will be discussed, you all will know what is important in the
Yes,
examination. From most of the question comes from that and from the assignment questions.
Yes. Okay. So
Okay.
best of luck. I hope you perform well in the examination. Over to Dr. Naik.
Thank you, sir.
You do not leave. Okay. Dr. Naik will join and continue your class. And tomorrow we shall meet at 5 p.m. in the same league. Thank you.
Okay, sir. Thank you, sir.
Shall I start?
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir. Yes, sir.
Yes, sir.
Is slide visible?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Yes, sir. Visible, sir.
Okay. Today we discuss about central force motion and its applications. Okay. Whenever we discuss about central force motion, basically there are two important examples actually due to which we exist here. One example is stability of atom, another is stability of the solar system. You know, in solar system, all planets are revolving around the sun uh, due to gravitational force. Uh, and inside atom, electrons are revolving around the nucleus due to which type of force? Which force is
Nuclear
responsible?
force.
Nuclear force. Electron revolving around nucleus. Electron is outside the nucleus. Nuclear force is a short range force which exists between neutron and proton inside the nucleus. Range is femtometer. But here electron revolving around nucleus. Electron is a charged particle, negative charge, and nucleus is a positive charge. And the force between a two charge comes under which force?
Electrostatic force.
Electrostatic force. Yes.
Yes, sir.
So stability of the nucleus, the electron are revolving around nucleus, is due to electrostatic force. But if you see both type of forces, you know in your gravitational forces, force is proportional to 1 by r square, or if you write exactly, gravitational force is G
M1
m1
M2 by R square.
m1 m2 by r
R
square.
square.
M1 is the mass of the first tablet. Let's say Earth, M2 is the mass of Sun. And here, uh, electrostatic force is
F is equal to K Q1
K
Q2
Q1 Q2 by R
by
square.
R square.
If you look these two expressions, it looks similar, isn't it? It varies charge, electrostatic force due to charge, uh, gravitational force due to mass, and other thing is 1 by R square, 1 by R square. Okay. So these two type of force comes under one single force, which is known as central force. What happens here actually in the motion of Earth around the sun or electron around the nucleus, your force is directed towards the center, either nucleus or sun. So central force property is that force is directed either towards or away from a fixed center. Second thing is here, uh, for both forces are proportional to 1 by r square. Force depends on the distance between the two objects. Okay. So if you see since force a vector, its direction will be r cap. Maybe plus minus is towards or away, but it is r cap. Okay. Another property is, let's say, I can write center f is equal to function of r. So it is not r vector r cap.
R cap, sir. हाँ.
R cap, R cap. Okay. And actually, function of r into r cap. If this function of r is a scalar quantity, if it is positive quantity, then the force is a repulsive force. If this F of R is a negative quantity, then the force is a attractive force. Suppose for this electron and proton, charge of electron is minus E, charge of proton is plus E. So it is not minus K E square by R square. So function of R is negative magnitude. So it is a attractive force. If both are electron, then minus E, so it becomes plus. So it becomes a repulsive force. Here similarly, actually this quantity there is a minus sign because gravitational force is always attractive force. If you see exactly, the magnitude of that force is minus g m1 m2 by r square into r cap. Okay? This is a property of central force. Okay. But we have written here motion around the sun. Okay. The force is said to be a central force if it is always directed towards or away from a fixed point called the center of force. And the magnitude of this force is a function of the distance from the fixed point. Mathematically, central force can be written as function of R12 is equal to R cap or R12 cap FR2. Why I am writing R12 means I am here using the position vector of earth is r1, position vector sun is r2. So distance will be r2 minus r1. But in general, we assume is the center origin is at the center of force. So if it is the origin, then distance we assume r. If we choose the origin as the center of force, then obviously r12 reduces to r. R12 means r2 minus r1. The one of its origin 0, then obviously rest the distance. Again, we can write this as r cap fr. If fr is greater than 0, then force is repulsive. If fr is less than 0, then force is an attractive force. Clear? Hello?
Yes,
Yes,
sir.
sir.
So now, what is the torque? Since you know the rotational motion, there exists torque. What is the torque exists between sun and earth? We know torque is equal to
Force
r
into
cross F. Isn't it? So can you tell
Yes,
anything?
sir.
So torque, how much torque? So here r cross, we know force is r cap into Fr. So can you guess any value for this? This will be how much? R vector cross r cap. R vector means you know that what is magnitude r into r cap. So cross product of same vector is equal to, hello, cross product a cross b, a b sin theta. If the same vector, then theta will be how much?
0, sir.
0. So sin 0 is equal to
0.
0.
0.
0.
So result is 0. So here torque is 0. Torque 0 means what is conserved? If the total torque acting on a system 0, then which quantity becomes constant? Which quantity? Hello? We have already discussed torque is equal to dl by dt. What is L?
Angular momentum.
Angular
Momentum.
momentum.
If torque is equal to 0, then angular momentum is a constant quantity. Angular momentum is a constant. So we found angular momentum is a constant quantity. A constant vector means its magnitude is constant, its direction is constant. Okay. So L magnitude is constant, its direction is constant. But what is L? You know angular momentum is equal to, what is the expression for L? R cross
R cross P.
P. So we found that here R cross P is a constant. Always R cross P is constant. P actually basically mass into velocity. You know it. Mass is a constant, so I can say mass is a constant of particle R cross V. So R cross V is always constant. During the motion, what is suppose here sun and here earth revolving around it. So R is this one distance. R V is its velocity. Depending on the motion in direction, it will be giving V tangent to this. So R cross V. Cross product obviously. If you have R cross V, it will towards up. Isn't it? R cross V. Okay. If you take opposite towards up or down, no? Okay. The distance actually R cross V. So R cross V is a constant vector. So what it means? Always R cross V is constant. Whether it is up or down, doesn't depend. If up, always up. It towards up. So motion will be where? Up means motion lies on this, let's say the seat or the desktop, because RV always towards U, let's say. Is a fixed vector. Always towards this means motion is always in this way, always on the plane of your laptop or mobile, isn't it? R cross V is always constant. So motion is such that R is always a fixed. R is distance from sun to earth. It will be always like this. R on the plane of the laptop or mobile. Then V. V is also similarly. So what it means? Since L is constant, we cannot change the V and R. We cannot take from this plane. That means R and V always lie in the plane, or in other words, central force motion occurs in a plane. Plane means we need two coordinates to solve the problem. Clear? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
So in the exact
Yes,
figure,
sir.
R cross V, so it always if the direction, if R is in this direction away from a center, then J direction is fixed. So always motion occurs in a plane. A plane means we need only two coordinates. So we use polar coordinate R and theta to solve this. Okay. So it is also known as spherical symmetric problem. So for spherical symmetric problem, in the angular momentum is conserved, so it is not affected by rotation. So we use non-Cartesian coordinate. Actually, plane polar coordinate is used to solve this problem. You already know about plane polar coordinate r theta. They are related to x, y as x r cos theta, y r sin theta. Okay. So next we go for equation of motion. So using plane polar coordinate, the Lagrangian of the system moving under central force can be written as, because from Lagrangian, we using Lagrange equation of motion, we go for equation of motion. Lagrangian is equal to T minus B, T is equal to half. Since there are two bodies, one is Earth, one is Sun. So for two body system, we actually use reduced mass. The term reduced mass, you know, reduced mass. Why it is called reduced mass? Because it is less than both masses. If this mass is m1, this m2, reduced mass is less than m1 and less than m2, and we can find it from formula 1 by mu. Reduced mass mu is equal to 1 by m1 plus 1 by m2. If you simplify, you get this. Mu is equal to m1 m2 by m1 plus m2. Okay, I think you know it. Isn't it? Hello? Have you heard
Yes, sir.
reduced mass? You know already in plus
Yes, sir.
2 and plus 3. Okay. Reduced
Yes.
mass term, when we discuss two body motions, actually we use reduced mass. And that reduced mass formula is 1 by mu is equal to 1 by m1 plus 1 by m2. And mu is always less than both m1 and m2. Okay? So suppose here m2 is mass of sun. M2 is much larger than m1. So if m2 is much larger than m1, we can write this term. When we add this, m1 can be neglected. So finally m2 neglected, it is equal to m1. If one is heavier, then reduced mass equal to mass of the light object. Okay? It happens in our both the cases because sun mass is much heavier than earth, so our mu is nothing but mass of earth. Similarly, for motion of electron or nucleus, electron mass is much less than nucleus, so our reduced mass is nothing but equal to the mass of electron. Okay? Hello?
Yes, sir.
So
Yes, sir.
using
Yes, sir.
Lagrange's
Yes,
equation, we
sir.
can solve it. Like here, two coordinates, we have one r and theta. Though theta is cyclic here, theta is absent. So cyclic coordinate p theta is conserved. But we have two coordinate, one r and theta. We have two equation of motion or two Lagrange equation like this. Okay, we solve in the next slide. So I am not going to do body reduction. If you want, also I will reduce. I have already told that it is actual procedure how two body reduces to one body. And what we told about, you know it. I am not repeating this. It's not so important. Okay. But if you want, I can give you the slide, you read it. Okay. It's not so important. Okay. Then go to first integral. Because I have to cover 2 units in one class. Actually, whatever syllabus is given in your part 2, it is more than 2 units of other university MSc syllabus. I have to cover that in one class. Okay. So equation of motion on central force and fast integrals. Okay. We already suppose this force is conservative. Actually, we study conservative forces. No? Gravitational is a conservative force. Uh, so if a conservative force, then force can be written as negative gradient of potential. So this central force which form is arc of F, it can be written as negative gradient of potential in magnitude and vector R. Because F is equal to minus del V by del R into R cap. Okay. Now come to Lagrangian, we know it Lagrangian. This one, where theta is cyclic coordinate. So corresponding momentum is a conserved quantity P theta. P theta is equal to del L by del theta dot. We know that formula using mr square theta dot. Now Lagrange's equation in theta becomes, if we do del L by del L 0, so only this theta dot is equal to mr square theta dot. Derivative of mr square theta dot is equal to 0, which implies mr square theta dot is a constant. So J is the constant magnitude of angular momentum and it is a conserved quantity. Okay. We already know for angular momentum is a conserved for central force motion. Again for Lagrange equation in R. This is equation R, del by del R, del L by del R dot. If you calculate this, we found derivative of mr dot minus mr theta dot square for del VR by del R is equal to 0. That implies derivative is mr double dot minus mr theta dot square is equal to, taking the right side, minus del VR by del R. So putting in place of theta dot j by mr square, because mr square theta dot is equal to j is a constant. So theta dot is equal to j by mr square. I found this. This is very important equation. Mr double dot minus j square mrq is equal to function of r. So mr dot is equal to j square mrq minus f of r. But in our equation of motion, Newtonian mechanics, we know equation of motion is What is the equation of motion? Force is equal to, hello? Equation of motion, no? Mass into acceleration. Acceleration means d square r by dt square. Isn't it? dr by dt velocity, d square r by dt square acceleration. This is our equation of motion. Please look here. Left hand side is same. Double derivative means d square by dt square. Right hand side is something minus fr, I think. Okay. Okay. F is equal to, we are right actually fr r cap. It may be plus or minus sign. Leave the minus sign. But here there are two terms. We actually call this effective force. Okay. We go for that. Now write it. But we know that force is negative gradient of potential. So Fr can be written like this. This term also written like a derivative of some quantity. So finally we got mr dot is minus del by del r derivative of this quantity. If the right hand side is the force, then this bracketed term with the potential. Must be a potential. Because equation of motion mr double dot is equal to Fr. Or mr dot double dot is minus del v by del r. So this is actually behaves as a potential which we call effective potential. Okay. Okay, we go in the next slide. Now, what is significance? Let's say we want to get some conclusion from this equation. Conclusion is for that we actually do some mathematical simplification where is multiply r dot in both sides. So we got this equation, but this left hand side can be written as after this derivative of half mr dot square. Derivative of half mr dot square is 2 mr dot r double dot. 2 have cancelled mr dot r double dot. Right hand side is del by del r. R dot means dr by dt. So using reverse chain rule, del by del r something into dr by dt. So I can write minus d by dt of this quantity. Okay. This is the thing. If you use chain rule, I can write minus del by del r and dr by dt. With reverse chain rule, I can write this. So now both side d by dt. Taking into one side, I can write d by dt half mr dot square. This minus goes to plus, minus goes to plus. Here is equal to 0. So derivative of a quantity is 0. But what is this quantity? If you see, this is half mv square, kinetic energy, T. And this is potential. But if you see here, actually this term is effective potential. So T plus V prime effective potential is a constant. Actually here effective potential behaves as potential energy. So kinetic energy plus potential energy is a constant quantity, which is nothing but energy. Also you can write, if you expand energy in terms of polar coordinate to get that expression. This is T plus V, kinetic energy half mv square, but in polar coordinate v square is equal to r dot square plus r square theta dot square. In place of theta dot, you can use j by mr square. Using this, we got this expression. But total energy is also constant. So in central force motion, angular momentum is a conserved quantity. Total energy is also a conserved quantity. Okay?
Yes, sir.
Yes, sir.
Then from this equation, we also find the differential equation of orbit. Differential equation of orbit means the relation between two polar coordinates r and theta. How r varies with theta. The equation involving the dependence of r upon theta by eliminating the other parameter time is called equation of orbit. Only r variation of r with theta. Okay. So we have a equation. What do we box? This one. Fr is equal to mr double dot minus j square mr cube. Okay, we have that equation. Now put r is equal to 1 by u. If r is equal to 1 by u, then what is r dot? The chain rule d by dt of 1 by u. R dot means dr by dt. d by dt 1 by u means du by du 1 by u du by dt. Its derivative minus 1 by u square du by dt. But here we need r double dot. Then what is r? Sorry. Here r double dot. I made a mistake. Then what is r double dot? R double dot is my
So screen not visible.
skin is not visible.
No.
Hello?
sir, visible.
Visible, sir.
Yes, sir, visible.
Okay. I think your network problem, even not visible. Okay. ठीक है. So r dot is equal to minus 1 by u square du by dt. Now I can convert it to want to remove the t. As per our definition, we have to remove t and only establish relationship between r and theta. So how I can remove t? For that I slightly rearrange du by dt using chain rule. I write du by d theta into d theta by dt. If d theta cancel, it du by dt. Okay. So now, but d theta by dt theta dot. So minus 1 by u square du by d theta theta dot. But theta dot is equal to j by mr square. Putting that, I final. But u is equal r is equal to 1 by u. So what is u square into r square? Hello. If r is equal to 1 by u square into r square is equal to
1.
1. So it removes. So it finally found minus j by m du by d theta. Okay. Now t is removed, only u and theta. Other things are constant. Then go for r double derivative. So I take its derivative again with respect to t, minus j by m constant. So d by dt du by d theta. Again use chain rule. D by d theta into du by d theta into d theta by dt. D theta by dt theta dot put to j by m r square. So finally I found r double dot is equal to minus j square u square by m square into d square u by d theta square. Put it in that our expression fr mr double dot minus j square mr cube m r double dot j square mr cube. R is 1 by u, so it will be u q here in the numerator. So finally found function of 1 by u is equal to this, or d square u by d theta square plus u is equal to minus j by j square u square function of 1 by u. This equation is the differential equation for the orbit if the force law is known. If you know the fr or f1 by u, then you can solve this problem and find the orbit. Okay. Conversely, if the equation of orbit is known, you can find f of 1 by u or fr. And here you see, if you write minus theta in place of theta, then what happens? Suppose I use minus theta. Minus theta square is plus theta, so it remains invariant. So changing theta does not affect this. Okay. So orbit is symmetrical about that point, which is called turning point. So invariant on the theta and minus theta. Okay. And one important thing we actually discussed. One thing, suppose we throw a stone to up, then you see stone then come back like this. Okay, ground. So what happens here? Why it falls down from this point? Hello?
So velocity 0.
Here velocity becomes 0.
0. Yes.
So if velocity becomes 0, then what happens to the system? True, velocity becomes 0. Velocity becomes 0. So what is the total energy? Kinetic energy plus potential energy. If velocity is 0, what is kinetic energy? Hello? Kinetic energy is half mv square. If velocity is 0, 0. So total energy becomes potential.
Zero.
Potential energy.
When total energy becomes potential. Another example, suppose we are throwing a ball in the ground. It will roll down the ground and stop here. So why it stops here? What happens here? Ball is rolling on the floor and stop here. The stop means its velocity becomes
0.
0.
Zero.
So total energy is
Potential.
potential. So whenever total energy becomes potential, ହଁ ଏ ତମ ଯୋଉ ସେମିନାର ଫିଟା ଦେଇଦେବ ନହେଲେ ତମର ହେଇପାରିବନି ଷ୍ଟୁଡେଣ୍ଟ ଆକ୍ଟିଭିଟି କ'ଣ ଆଉ ଦେଇଦେଲ ମ୍ୟାଡ଼ାମ ମନା କରୁଛନ୍ତି 16,000 କେତେ ଦେଇଛି 14,000 ଟଙ୍କା ଆଡିସନାଲ ଦେଇଥିଲା ତ 16,000 କେତେ ଦେଇଛି 16,754 ଟଙ୍କା ମ୍ୟାଡ଼ାମ ଆସନ୍ତୁ କାଲି କଥା ହେବା ଠିକ ଅଛି ହଉ One minute, please.
Yes, sir.
Okay. Hello?
Yes, sir.
So here, in both the case, total energy is potential. You know it? Total energy is potential. So what it means? If total energy approaches potential energy, either you change your direction of motion, otherwise your motion stops. When total energy becomes potential or approaches potential, you should change your direction of motion. Otherwise, your motion stops. Isn't it? One of the basic principle of physics, as a mechanics, it is applicable to everywhere. Okay. Suppose you are proceeding with some or following some procedures, you are not getting any success. Then you have to suddenly change your direction of motion. Eh? But you have also seen politics. If someone is not neglected in that party, suddenly he started opposing that party. Not it. Otherwise, his political career will be finished. Okay. Similar case, it is applicable to everywhere. When your total energy approaches potential energy, you should change your direction of motion. Otherwise, motion will stop. Okay. Where this the motion of changes its direction, that point is called what point? Where actually change occurs. In the cricket match, where change occurs. What do we call? That point is? Hello?
Yes, sir.
What point? It
When
called?
E equals to V.
No, I am not telling that E is going to be. What? Where
Twist, sir.
sudden change occurs. Suppose change of occurs. Suppose there are 50 runs to win. Suddenly one bowler came and take hat trick. What do we call that situation? Then
Critical
that will be
points.
limited. Huh? That point we call some turning point. No, we call turning point of that. Isn't it? Turning point means where actually the direction changes. So when total energy becomes potential, the body changes its direction of motion, and that point is known as turning point. Okay? At turning point, body changes its direction of motion. Okay? Hello?
Yes,
Yes,
sir.
sir.
Yes, sir.
So, okay. We go for that actually. We are discussing this. The next is classification of orbit. So, okay, we have already discussed this. So we got this equation mr dot is equal to j square by mr fr. So we can write mr double dot is equal to j square by mrq plus fr. Okay, we call this as f prime r or effective force. We already know effective potential, and this is effective force. Effective force is equal to fr plus j square by mrq. Okay. Or from that we can calculate effective potential. I'll matter it. Okay. What will be del R? You know, we already discussed that. V prime is equal to this. Okay? VR plus J square by 2mr square. This is your V prime. So now we take this as our potential for the central force motion. E is equal to T plus V. T is equal to half mr dot square. Instead of V actually, we take V prime. So T plus V prime. So for central force motion, effective potential we assume as its potential energy. So this is kinetic energy, this is potential energy. Okay? So at turning point, T is equal to 0, isn't it? So which one is 0? R dot is equal to 0. At turning point only is V. So T is equal to 0 means R dot is equal to 0. But J square is non-zero means theta dot is non-zero. Sometimes ask which component of velocity is 0 at turning point. Which component? Radial component or tangential component? Hello?
Radial component.
Radial component vanishes at turning point. Okay. So V prime R. So orbit under inverse square law of force. Okay. So now we have three terms actually, half mr dot square Vr j square by 2mr. Or if you say V prime R means sum of these two. Okay. So now we want to plot it. Because we know when E is equal to V, that point is the turning point, body changes the direction of motion. So here for central force motion, we call E is equal to V prime. When E is equal to V prime, at that point, body changes the direction of motion. Okay? So now we plot V prime, then we assume E lines. So that this point is a turning point, this point is a turning point. Okay, plot this V prime. Actually, this is the plot of V prime. V prime has two parts. One is VR plus J square by 2mr square. For particularly for Kepler's problem means motion of the planets around the sun, VR is equal to how much? Minus K by R. Is not it? K constant, it contains G actually. So that force will be R square 1 by R square. Some constant in 1 by R square. Force will be minus some constant 1 by R square. In motion of the planets around the sun is the force. Isn't it? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
That constant K contains G in other things. So force in attractive inverse square law. Actually, orbits under inverse square law of force. Actually, attractive inverse square law. Some gravitational field is attractive field. Force is minus K by R square. So potential is equal to minus K by R. This is VR. So here the plot of to compare. Not necessarily. It's a dotted line is this is minus K by R and this term is extra term. So J square by 2mr square. J square by 2mr square. Okay. Now look at this figure. It is our actual graph V prime. We know when total energy becomes potential, it is a turning point. For that, now we assume few energies. E1 is one energy, which is a positive energy. E2 is another energy, which is zero. E3 is another energy, which is negative. E4 is another negative energy, where potential energy is minimum. It's the minimum value of potential energy. Okay? So then we try to picturize the motion. How we picturize? Because we know when E becomes V prime, it's a turning point. So this point is basically a turning point. If particle has energy E1, here we have this is V prime graph, here it has a kinetic energy. This is T or half mr dot square. We know E is equal to half mr dot square plus V prime r. So this difference is equal to half mr dot square. It has a kinetic energy, it is moving, and when coming to this point, it cannot go beyond that because your total energy becomes potential. So here body changes its direction motion. The particle coming from here go back. Okay.
Yes, sir.
Similarly, for E2 is equal to 0, case is similar. Here one turning point. It comes difference somehow positive and go back. It is given here. So for case 1. Case 1 means E1 greater than 0. This is positive, but it cannot go beyond this region. If this is R1, so R less than R1 is not possible. Becomes potential energy becomes negative. This potential is greater than E1. It is to E1 means total energy. E potential energy. This point potential is greater. So means kinetic is negative, which is not possible. So R is less than R1 is not possible for this motion. So if a particle approaches from infinity to that point, it will go back at certain point at R1. Okay. So R1 is the turning point here. Second figure, and for E is here I have written actually for showing that motion. I am plotting a figure. This is particle is coming, just going back like this R1. Case is same from E0. For energy 0, only one turning point. Motion is just like same. But what happens when E2 is here? If you look, but for E2 case, E2 process this V prime at 2 points. So what it means? Okay, what it means? Well, we see in this slide. Okay. This point. For E3, actually there are two turning points. Turning point means suppose particle is moving Here it is change directional motion. Again here it is change directional motion. So what is the motion? Motion
Elliptical.
is bounded motion between 2 points. Yes, is the actual motion for the earth around sun. Energy is negative, and it is a elliptical motion particularly. But any kind of bounded motion is possible. Clear? So case 3, which is actual case of rotation of earth around sun, orbit is elliptical because there are two turning points. The turning point direction of changes, changes. Okay. But when it becomes minimum, you see, this is your one distance R1 and R2. But this point, this distance decreases. Here 0. It is R1. It is R2. Okay, second figure it is given. Here. For this point actually, for this point R2 decreases, R1 increases. For this line, R2 decreases, R1 increases. R2 decreases, R1 decreases. For this point, what happens? Hello? R1, R2, what is the relation between them? For this point, what is the relation between R1 and R2?
R1 equals to R2.
R1 is equal to R2.
Sorry, R2 greater than R1.
Yeah, R2 is decreasing for each line decreasing, R2 decreasing, R1 increasing, R2 decreasing, R1 increasing. Finally, you get a one point where R1 is equal to R2 with a minimum potential. That means for the ellipse, we have two axes, semi-major axis, semi-minor axis, R1 and R2, both have become same. What we call it?
Circle.
Circle. So in this condition, it becomes a circle. If a minimum potential, that is a circle. Okay. So minimum potential, we have one radius, which is a circle. One radius obviously at 0 is a circle. Okay. What is that condition? For minimum, actually we calculate this. We know that f prime r is equal to del v r by del r. This becomes 0. That point. A circular orbit, f prime r be 0. Okay. So f prime r 0 means fr plus m r theta dot square by r 0, or fr value is minus m r theta. mv square by r circular motion. The magnitude of fr is equal to minus m r theta dot square by r. Okay. So what is that value? We know v prime is equal to this. For r is equal to r0, v prime is minimum with the case of circle. For circular path, v prime is minimum. So what is the minimum value? How we calculate? We know for a constant value, we know its derivative is 0. Minimum means if its second derivative is greater than 0, then what happens? Hello? Minima occurs, na? Okay. That is for checking maxima and minima, you will take second derivative, whether it is positive or negative. Okay, now it is a minimum quantity. Minimum means a constant. We cannot decrease more than that. If you decrease it, it becomes 0. So it is minimum. Its derivative will be equal to 0. Taking its derivative, we found, and equating it to 0, we found R0 is equal to J square by MK. Okay? Hello?
Yes, sir.
Yes, sir.
Putting here R0 here and using this R0 value, we found total energy at the minimum point is equal to minus MK square by 2J square. Okay. Whatever we found actually on the shape, positive energy case is actually this like high parabola. But energy 0, actually two types are possible. It is a parabolic case. 3 negative energy ellipse. 4th energy is a circle. Okay. This is the analysis from equation. we found it, but now from Kepler's law we also found same type of orbit classification mathematically. Here we analytically found this nature, but from mathematically we also found from Kepler's law. And this type of behavior is valid for the potential which falls off slower than 1 by r square and becomes infinite slower than 1 by r square. Means if force is equal to 1 by r square, the potential. Our potential is equal to, we have write minus k by r. Is not it?
Yes, sir.
But this analysis is true for minus k r to the power n, where n varies between 0 to 2. Our case 1, but it is true for 0 to 2, same nature. Okay, same general qualitative division, open, bounded, circular orbit, true for attractive potential that falls off slower than 1 by r square, means n varies between 0 to 2. Okay, then go for Kepler's problem. Inverse square law of force. Okay, actually John Kepler gave 3 laws of planetary motion which are known as Kepler's laws of motion. First law is law of elliptical orbit. Every planet move around the sun in an elliptic orbit with sun at the one of its foci. Foci means plural of focus.
Focus.
There are 2 focus, F1, F2. The sun is on one of the foci. So no, that's opposite the Earth. So when Earth is this point, we actually nearer to sun and it is summer season. And when we are here, the winter season.
Winters.
Perihelion and aphelion distances. Okay. So what is the average distance between sun and earth? Hello? What is the average distance? What is the distance from the sun between sun and earth?
150 million.
Because how you calculate this? We know distance. Velocity is equal to distance into distance by time.
Time.
So distance is velocity into time. Actually, light takes nearly 500 seconds to coming from sun to earth. So if you multiply with velocity, speed of light c with 500, you found that 15 crore kilometer. 15 crores. 5 into 3 into 10 to the power. C value is 3 into 10 to 8 meter. Hello?
Sir, sunlight takes 8 minutes, 20 seconds.
8 minutes 20 seconds means convert 500 seconds. 8 means 8 into 60, 480 plus 20,
Yes,
500. 500 seconds. 3 into 10 to 8 into 500. Second cancel. Meter. So it will be 15 into 10 to the power 10 meter. If you convert kilometer, 15 into 10 to the power 7 kilometer. Means 15 crore kilometer. The distance between sun and earth is 15 crore kilometer. Huh? But Aditya L1, but India sent how much distance it will cover? Hello? Aditya L1, India sent to sun, isn't it? So it will cover how much?
1.5 million.
1.5 million.
1.5 million. Means
1.5
15
million
into 10 to
kilometers.
the power 5. 1% distance. Okay. So if is sun from 100 kilometers, then it will 1 kilometer cover. It is, isn't it? 1%.
Yes, sir.
1% distance. Okay, we have only cover only 1% distance, but we have not some material who, we can survive in so high temperature. So whatever we made, it is only cover 1% distance. Okay. Okay. Second law is law of area. The radius vector drawn from the sun to a planet sweeps out equal areas in equal time interval. So it covers equal area in equal time interval, which is also called aerial velocity of planet is a constant. Third law, the square of time period of revolution is directly proportional to cube of semi-major axis of the elliptical orbit. T square proportional to AQ. Now it is not plus 2. Okay. So basically, our second law is comes from the conservation of angular momentum. Okay. We see. Okay. First, try to prove the Kepler's first law. No? We have this expression for total energy. Half m r dot square is plus j square m v_r. From that, it's just simplification. You can find an expression for r dot. Half m r dot square is equal to taking this to all thing right hand side. Only r dot term in the left hand side. We found this very easy. But r dot is equal to dr by dt. So dt is equal to dr. Okay, cross multiplication by that. Again we have j is equal to m r square theta dot. Theta dot is equal to j by m square. Theta dot is equal to d theta by dt. D theta by dt is equal to j by m square. So dt is equal to m square by j d theta. In both 1 and 2, left hand side is dt. Now equating right hand side, we found this d theta is equal to this. So d theta is equal to j by m r square, this quantity. Now slightly rearrange this. This is m. So if I divide here, I can take it to here m. I can write here m is what? 1 by m. Is not it? M. Okay. Again, when m enters to a root over, I write m can equal to root over of m square. Is not it? Hello?
Yes, sir.
Yes, sir.
It's the rules. So now first m is equal to root over of m square. So when it comes under root over, it becomes m square. So again one thing j. J is here present. So j is 1 by of j. So I write j here j. I write 1 by of j. That means here I write 1 by j. That j enters root over as j square. Okay. Hello?
Yes, sir.
Yes.
So now you multiply this inside this. So 2m by m1 cancel. 2m by j square into e by this. So now multiplying 2m by j square with each term, we found this equation. 2m by r square, 1 by r square, j square of er. But for inverse square law of force minus k by r, potential minus k by r. So now we found this equation. Put u is equal to 1 by r. For simplifying this, if u is equal to 1 by r, du is equal to minus 1 by r square dr.
Yes,
Okay,
sir.
put this. We found dr in place of dr minus 1 by r square dr means u square dr. Again u square, so 2m by j square, we found this. Okay, here 1 by r square dr, this term means minus du. Then 2m by j square e minus 1 by r square is u square plus 2mk by j square 1 by r is equal to u. So d theta is equal to minus integration of this. Okay, so theta is equal to let's say limit from theta prime to theta. So theta is equal to theta prime is a constant. Theta is equal to minus of this plus a constant of integration.
Theta dash.
It is let's say constant of integration. So now solving this we found theta is equal to theta prime minus this. Next we have to integrate it. This is a variable is u, some kind of from u square u quadratic equation, isn't it? So we know if alpha plus beta x plus gamma x, like this form, where actually gamma minus 1, beta 2mk by j square, alpha 2m by j square. Okay. But this integration can be done by substituting this alpha plus beta plus gamma x square, you know, in a plus 2, we actually square it in terms of squaring this and simplifying. I'm not going details, all are given here. Okay, integrating, we found this. This is basically cos inverse y by c. This minus 1 by gamma root over cos inverse y by c. Y by c means y, what we substitute here? Okay. All substitute, y is this, c is this, putting is the result. But, alpha is this, beta this, gamma this, putting all value, we found the cos inverse j square u by mk minus 1 by 1 plus j square 2e. And taking one side cos theta minus theta prime, taking cos of both sides, cos theta minus theta prime is this. And again cos of minus x is equal to cos x. So minus has no meaning here. So j square u by mk minus 1. Taking cross multiplication, we write this. From this I can write u is equal to mk by j square into this. This is the equation of orbit. Okay. All are given here. You have to check only. Okay.
Yes, sir.
Yes.
This is our equation. What is the general equation of conic section? You know in your plus 2 book, conic section equal 1 by r c 1 plus epsilon or e cos theta eccentricity. This term is called cos theta minus theta prime. Comparing this, we found eccentricity is equal to this one. Actually, eccentricity determines the shape of the conic section, whether parabola, hyperbola, ellipse or circle, that depends on eccentricity. This quantity 1 plus 2 square j by m square. Okay. So this quantity, when e is positive, e greater than 0, 1 plus e greater than 0, so eccentricity greater than 1. That case is hyperbola. When e is equal to 0, eccentricity is equal to 1, so case of parabola. When e negative less than 0, eccentricity 1 minus something means less than 1, so root over e less than 1. In that case, ellipse. If eccentricity is 0, this term is equal to minus 1, then e is equal to minus m, because that case is circle. What we found in case of orbit. Okay, this classification agrees with the qualitative discussion what we done in the previous slides. Okay, it is all about classification of orbits. There are other things, small oscillation, scattering. Okay. It is not possible to discuss today. Okay, there are few things left from this section. Actually, we will discuss when we start in the classical mechanics 2. Okay.
So tomorrow, will you have any class?
No, actually.
Gauri Shankar sir will have their class.
Actually, tomorrow I have a meeting on the time. So.
Okay, sir.
I
Sir,
will discuss in
I
that
want to
class.
say that, sir, after everything gets over on the last class, can we discuss the SAQ and TQ that are all given in the IGNOU books after each topic?
Yes, yes. Then no problem. Okay.
Yes, sir. Thank you.
Okay, okay.
Sir, send this PDF in the group.
Okay.
Okay, sir. Thank you, sir.
Okay.
Thank you, sir.